So when I run into a problem, how do I examine the problem? What preconceived notions do I have that limit my ability to address the problem?
Welcome, listeners, to the Industrial Security Podcast. My name is Nate Nelson. I'm here as usual with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how's it going?
I'm very well, thank you, Nate. Our guest today is Dr. Arthur Conklin. He's a professor at the University of Houston. He is the director of the Center for Information Security Research and Education at the University of Houston. And he's going to be talking about how lenses blind us. And just a note, we did record this outdoors, so there might be wind and other noise from time to time. My apologies.
Okay, then without further ado, here's you and Art Conklin.
Hello, Art, and thank you for joining us on the podcast. Before we get started, can you tell our listeners a little bit about yourself and about the good work that you're doing at the University of Houston?
Well, thank you for the opportunity, Andrew. I really enjoyed other podcasts I've listened to from you, and the opportunity to present a podcast will be exciting. I want to talk about lenses and how we look at things in cybersecurity. And as you mentioned, I'm at the University of Houston. I'm a professor in the College of Technology. We're on a Master of Science program in cybersecurity, and we examine cybersecurity from a perspective of technical. We also look at it from a social economic perspective, from a managerial perspective, because you have to look at all these different methods and all these different ways of looking at something if you're going to be in the real world and actually be able to do things.
Okay, and our topic is lenses and how they blind us. I mean, it doesn't sound like industrial security. Can you connect the dots for us? What lenses are we talking about?
Lenses is a term that scientists and others have used to describe how you perceive a problem, how you examine a problem. So ultimately, we're talking about problem solving, and cybersecurity is one of the more challenging areas of problem solving today. And so when I run into a problem, how do I examine the problem? What preconceived notions do I have that limit my ability to address the problem? And so by using the term lens, I'm describing a preset series of preconceived notions that a problem solver brings to the problem. And there are a lot of things we've done historically in business over the years to combat lenses. And are we doing that in the cybersecurity arena? Are we saying, oh, this is too hard, I can't solve it, only because I can't see a better solution?
Okay. And, I'm going to ask you for examples here. We're sitting here just outside the venue at the American Petroleum Institute Cybersecurity Conference. One of the topics that people have been talking about, at the event here is the shortage of people, the shortage of people skilled in the art, and how hard it is to do industrial security as a result. Is there a lens happening here that is confusing us?
Oh, I'm certain there's a lens. There's a series of lenses that are influencing here. If you turn around to the person that's currently involved technically in cybersecurity in an industrial setting, and they have a background in engineering and security, they're going to say, I'm a unicorn. I'm hard to replace. And they're going to look for somebody who looks like them. And historically, yes, we've grown into some of these positions, and that made the initial people getting in that are good really hard to replace. But the question is, do you need a whole bunch of those, or do you need new employees that can come in that understand something about the different realms? So if I turn this to an HR lens, they're going to say, why do we have to hire external? Why can't we take somebody internally in the company that understands the company culture, that understands what we make, that understands some of the basics of this stuff, and give them the additional skills, training, whatever's necessary, to develop them into the next unicorn. into that next cybersecurity OT professional. By the same token, why aren't we taking some of the current senior people that really understand all this and challenging them to mentor and grow others to fill their shoes rather than having them be the only problem solver? And so if you look at this from a lens of, I'm the OT guy, I'm going to say it's too hard. We can't get these. If I look at it from the IT guy, he's going to say, oh, well, we'll just apply we do in IT everywhere. If you look at it from HR, they're going to say, well, we have all these other HR methods we use to staff things. Which one is right? It's going to be a blend of those. You have to take off all those lenses, which I want to jump back to. I mentioned earlier that we've faced these problems before, and there was a move back in the 80s and 90s to have multidisciplinary teams, to go look at Myers-Briggs so that everybody in your team wasn't an extrovert. And so you'd have teams with varied psycho personality profiles because they have to solve problems differently. Well, that also removes lenses because you bring in people with different ways of looking at something. And so maybe the way to look at some of these problems is to stop asking the person that's stuck by the problem alone to solve it and bring in someone else. Because I guarantee you, if you call in a major consultancy, they'll come in and they'll have two answers for you. One answer will be, we'll provide you labor at a really expensive, exorbitant rate, because that's what they do. But their other answer is going to be looking at the problem in a way you never looked at it. And you're going to say, they're brilliant. They looked at it in a way we didn't look at it. Well, why don't we start looking at problems that way? Because we have the talent in-house.
So the phenomenon that Art is getting at there seems to me, after a few years of doing this podcast, Andrew, to be a somewhat global phenomenon. We've heard a lot of execs and engineers on the show talking about this. We've discussed it in our episodes with, I believe, CyberGym, with INL, with some others.
That is a problem. I mean, from my own experience at Waterfall, we have a lot of job openings that we've been posting for a while on our webpage. It's hard. It's really hard to find skilled people. But one of the other lenses that Art and I talked about sort of offline, we didn't catch it on the recording here, was, to your point, sort of the global issue. It's not, the job postings that Waterfall has open, for example, are not just OT cybersecurity gurus. It's also software development gurus and user interface gurus and a whole bunch of other sort of highly skilled technical positions. And Art's point was, another lens that people mistake, that they mess up, is they confuse a specific problem like the OT cybersecurity skills shortage with a global problem, which is pretty much in every economy on the planet. There is a shortage of highly skilled workers. And so we don't, we need to look at specific solutions like, OT cybersecurity training programs, but we also need to look at the bigger picture of recruiting more people globally into science and technology careers to fill this sort of global problem. It's, there's lots of ways to look at this problem. So that was a bunch of lenses. I don't know that I've seen a solution in your description. How do we solve the staffing problem?
Solving the staffing problem, it's going to get solved because companies are going to continue to run. They continue to need people. They're just going to have to find other ways. Well, when we say find other ways, if I bring a bunch of people to the table and the OT side of the house says, I need these 15 requirements that are my specific system requirements, somebody's worked in, God forbid they had things like 15 years experience in my company for an entry-level position. We see these things, and it rapidly becomes an over-specification because they're looking at it through their lens. HR department needs to fight back and say, do we need that specific? How about if we expand the pool of applicants by looking at people that have similar experiences with other companies' equipment? So you can just take any two, Siemens, Rockwell, Yokogawa, pick the company of your choice and say, well, that's the one I use. Does that automatically exclude all the others, or do you have to do a little retraining? And you might find that the person that comes in from another perspective brings additional value with the retraining. And so letting those lenses get stripped and having people challenge back, for instance, the requirements, solves staffing, not by finding people that don't exist, by expanding the pool. And so I'm changing what I'm looking for.
So Art is talking there about expanding the pool of talent that you're looking at, but there's something I think I'm missing here. You know, if we were the sales podcast, the marketing podcast, whatever other job you can imagine, then I would say, okay, the skills required in being a salesman can be taught to all kinds of people, even if you didn't go to business school or wherever you get salesmen from. But we're the Industrial Security Podcast. This is a technical field. This is a field with a high barrier to entry. So what does it really mean, Andrew, to expand the pool when you're talking about what amounts to very difficult jobs that take a while to learn?
And that's a good point. I think, part of the point here is that you can expand the pool, but only so far. So, to Art's point, we're dealing, his example was, recruiting someone with experience in a given brand of control system. And, maybe that's too specific. We can broaden it a little bit to say experience with any similar brand of control system. Because, between the brands of control system that are controlling, let's say, a municipal power distribution grid, well, the user interfaces are different. The commands that you give might be different, but the concepts are the same. It's the same kind of physical process. All of these control systems have to do the same thing. And once you wrap your head around the concepts, it's not that huge a leap to learn just a different way of representing those concepts in a graphic user interface.
That sounds well and good, but it also sounds like a big investment in whoever you're picking, right? If you're teaching them a new set of skills, that's time, that's investment. Is it really worth it by the end?
And that's a good point. And this is something that I think every employer in the marketplace for advanced technical skills is struggling with. You've got to widen your lens a little. You've got to bring some people in. You've got to invest in your people. And part of the solution is you've got to keep your people happy. You've got to keep them around. You've got to provide incentives to keep these trained people around that you've invested in. Otherwise, you're going to be spending a lot of money and not getting the return. So this is, again, it's in a sense part of the global staffing picture in every field that needs this kind of talent. This is the new reality. Let's say we do that. Let's say another classic sort of conundrum in the space is IT, OT, and how they see the world differently. I estimate there's something like 50 times as many IT people in the world, IT security people in the world, as there is OT security people in the world. Can we solve the problem by bringing in IT security? Is this a lens thing?
I think that the answer to this, is this a lens thing, can always be said as yes. Does that mean that the lens is the only problem? The answer is clearly no. And so the lens that comes up about, let's expand the pool for OT security by just bringing in our IT security people. Well, that has its own inherent problems. And we have to address those problems on both sides. One side will be the OT person saying, they're not touching our network. The IT person going, you guys don't understand how to do networking. I fixed it for you. And so you have to find that middle ground to where the person learns and becomes trained in what can and cannot happen, why and why not, and what the ramifications are of the actions. So, for instance, let's just look at networking. In networks today, most business networks are as flat as possible with as minimal latency. Everything can connect to everything because the whole purpose of the network is for information to move to drive our information-centric systems. Whereas in OT, the network doesn't exist for that purpose at all. The network exists for the purpose of control. we have a physical process that makes something, that does something that's what our company does. And I have to have some means of making that work for me as opposed to just doing it all on its own. I have a network that connects the devices and enables operators to properly control, safely operate, and today efficiently produce whatever it is your OT plant produces. The network enables that. It has nothing to do with about everybody talking to everybody. And so in one world, IT, I construct networks totally differently than in OT. In OT, the number one thing I can do for security is network segmentation. By segmenting the network and breaking it up into a bunch of little networks, that each little network controls its thing and is not influenced by things outside that little network, then I have optimal control. In the OT or in the IT world, they're going to sit there and say, well, why would you do that? Because of course everything should be able to talk to everything. Why can't your metal bending apparatus talk to your sheet metal painting apparatus, which then talks to your inventory control system? Why can't all these systems talk to each other? And the control person will say, because they don't need to, and I have no business value behind that. And so having somebody understand the business value aspects of putting all those pieces together is that missing part. So can an IT person come in and help OT? Yes, with training. Can an OT person be repositioned? Yes, with training. And so we have to sit down and thoroughly understand and explain to all the parties what it is I'm looking for. I'm not looking for an IT network engineer. I'm looking for an OT network engineer. I'm not looking for an IT risk management person. I'm looking for an OT risk management person. Now, if I understand networks, I can do both jobs. If I understand risk management, I can do both jobs. But someone has to sit there and help them understand that, hey, your lens from before needs to be changed. It's a sunny day. Get sunglasses.
But let me challenge that just a bit. I mean, IT networks aren't necessarily flat. I mean, the IT network is separate from the internet by a firewall. There might be a DMZ network in between with another firewall, or the same firewall with two ports. You might have your most critical, your SAP system or something, in another little zone. Is that really true that there's such a stark difference?
You bring up a really valid point, Andrew, and I'm glad that you brought this up this way, because we need to go explore the depths of this. And I put on fuzzy lenses there and oversimplified, whereas in reality, yes, IT networks have segmentation to a degree for certain purposes. OT networks goes to a much greater extreme. For instance, there's a safety network inside a lot of OT systems because some of these physical processes have safety considerations, things that if gone wrong, you have to call for backups of people because the original was lost, which is something we don't ever want to go down that road. You have to go call the board together for more capital equipment because you just destroyed your previous set of capital equipment. And so safety is a huge concern in many OT networks. And so you're not going to attach the safety system alongside the system it's protecting, because if something happens to the control side, the safety side independently has to be able to act to do what's necessary. And so the level of segmentation, the level and depth of segmentation. For instance, in industrial networks, there's something called a unidirectional gateway. I think that Waterfall might know something about these. They're critical in many places to provide ultimate isolation. They don't solve all your security problems, but they do resolve the problem of the wrong stuff going across the network, because there's no network to cross there. They put up an impenetrable barrier that separates things in such a way that enables specific things. Do we have use cases for those in IT? Sure, but a lot less. I think we could all agree that the Fed banking system probably should be isolated from the rest of us. But inside an OT environment, there are going to be many, many use cases for very strict isolation rules because of the processes involved and what the network's purpose is. And I don't need 50 million protocols whipping around. I have a very limited number doing very defined things. And so I think that the lens and the important, and again, putting on bifocals to be able to switch between seeing the whole field and seeing the detail where I need it is important. And in the OT world, there are places where we have to make certain people understand that detail and why we have that separation.
So Nate, I don't know if you caught that. It was, he went through it kind of fast. I think one of Art's points is, one of the lenses that IT people tend to look at their networks through is that most problems, not all problems, but many problems can be solved by restoring from backup. I install a patch and it doesn't work. The machine blue screens. Well, erase the hard drive, restore from backup. The machine's working again. I accidentally delete part of the operating system. Repeat, erase the hard drive, restore from backup, and you're back up again. Ransomware hits the network. Find the affected machines, erase the hard drives, restore from backup, and you're back up and running. One of his points was, if we injure or kill our people on the job in a serious incident, we can't restore them from backup. There's no backup for Joe. If we destroy a $300 million turbine because we've misoperated, you can't restore that from backup. So the scale of consequences, it's a different lens of how you look at things and how careful you have to be in certain operations.
Did you know that power plants are exempt from 1/4 of NERC requirements when those plants use Waterfall's unidirectional security gateways? NERC does not demand that power plants use the gateways, but the regulations recognize the strength of unidirectional protections. The regulations reward sites who use gateways by dramatically reducing the number of security rules for those plants. For details on the exemptions, please download Waterfall's latest report on the NERC standards. You can find the report on the waterfall-security.com website in the Resources tab under eBooks and White Papers.
Okay, so you've mentioned safety a couple of times. One of the sort of current topics in the field is analog safety. I mean, James McGlone and his colleague at Connexus wrote Security PHA Review. It's all about securing safety systems, and he's advocating, in a sense, a return to an earlier perspective on analog safety, spring-loaded valves. Physical centrifugal trips if your equipment's moving too fast. Is that another lens thing here?
I need to use the right lenses when designing these systems to include considerations of reliability, to include considerations of resiliency. And so I could ask an electrical engineer to build a computer circuit with all sorts of really cool bells and whistles that will look at a pressure in a pipe and say, if the pressure's more than this, activate the valve that closes this valve. And build a control circuit that does what I want it to do. But on the safety side, if all I need to do is dump excess pressure someplace, then a spring-loaded valve takes out all those components that could fail and replaces them with physics. That physics is physics. It always happens. And so it's simple. It's more reliable. It may not give me what I need in terms of, well, how much liquid did you dump there? That's a separate question. And so I have to be careful of the lenses of over-engineering to serve the wrong masters, as opposed to just going quick and dirty to a point. And so in many cases, some of our better answers to certain questions have been solved a long time ago. And we should adopt those where it fits the right need. understanding the purpose of what I'm trying to do in every circumstance is seemingly simple to say, but in reality, gets overlooked. If the purpose of a safety is to prevent X from happening, then you should really look at not X, Y, Z, A, B, and C, just X. And how do we do that? And in many cases, yes, older analog, mechanical, physics-based systems work great. Idaho National Labs talks about cyber consequence engineering and how if I want to make certain I don't put too much chlorine into my drinking water, then maybe I don't use a 1,500-pound tank of chlorine gas that's good for 60 days in my plant, that's always there, always available. Maybe I look at finding a way that makes it so that the most chlorine I can put in the next hour is 2 hours worth. And the pipe won't make any more. And that solves one of my problems of loss of key ingredients, all sorts of things. And so engineering against the right things, the right ways, without over-engineering, is a huge concern. And it comes from the lens of defining the problem narrowly.
So just a quick clarification. You gave the example of a tank of chlorine that might last 60 days versus a tank that's much smaller. I've heard complaints from engineers in water plants saying, that approach isn't necessarily the best one. We can't afford to have a truck full of chlorine at sort of a low diffusion level show up every 2 hours into the plant. That's too many trucks. Are you really talking about a smaller pipe to control flows versus a tank?
In some cases, I'm looking specifically at a tank because I'm going to take that bulk chlorine or bulk agent, chemical agent, and dilute it to a certain level that then works well through the piping that I want to use. And so how do I dilute that? Do I dilute that into a day tank? And then the day tank feeds my system? Or do I dilute it into just a stream pipe? And food safety is one of these areas where in the food industry we have batch control. And when I move from brown sugar batch number 14 to brown sugar batch number 15, I need to have separations in batches so I can have traceability. And so they're used to taking large quantities and using them in smaller chunks in such a way they have the control over their final outputs. And so we understand how to engineer these things. Just in many cases, out of convenience, it's like, well, I don't need to go through those extra steps. But if those extra steps solve a safety, a reliability, a resilience problem, they're worth it.
Okay, so we've talked about sort of the analog safety controversy that to some might look backwards looking, but in fact to your point is very simple. Let's look the other way. Let's look at the future. People point out the future is software-defined networks and artificial intelligence and cloud connectivity, which all seems in the direction of increasing complexity, and of course different kinds of security exposures. What are there? Have you got insights there?
Well, I'm going to say that I'm going to put on my business lens first, my set of business goggles, and say, if you ask the CEO and the business people, of course those things are going to come to the OT environment because those things have brought advantages where they've been employed effectively. And so it's suddenly now in the fine-tooth details. So I'm going to take off my broad business goggles and say, yes, we're going to take all this advanced new stuff and use it to enhance our enterprise, and put on the legal goggles. Those are the guys that have really, or the accountant goggles. They're really fine-tooth goggles that point out all the tiny little differences and say, well, what about this and what about that? And that has to happen. So if I take software-defined networking, and that is going to change networking as we know it, with the demise of network perimeters, with the demise of zones, with the idea that a network is where the data needs to go when the data needs to go there, and that defines the new network. Things like software-defined networking are going to provide us tools that will enable us to control that. Does that mean it just instantly replaces everything? No. That's where that accountant slant lawyer fine-tooth lens that connects the dots and say, in this use case, done this way, it's good. Let's go look at AI, artificial intelligence, machine learning, data science. It's already into our spaces. The Internet of Things is already into our spaces, where it makes sense, where it's giving us value. And so we should never be afraid of adopting new technologies. So we always have to have a lens that I'm willing to take off and say, what about? Put on my what about lens. What can this do for me? How can it do it for me? And then put my other lenses on to make certain, well, how do I take care of all these other aspects? And so data science is going to be here to stay in our industries. It's going to give us the numbers that enable a refinery to produce more money, which is the objective at the end of the day. It's not just more chemicals out, but more profitable chemicals. And so today, if I produce 1 part A, 2 parts B, and 3 parts C, but tomorrow, because of market conditions, A doesn't mean anything, then I need to be able to shift my refinery to get more B and C because A is not valuable tomorrow. And if my analytics systems with automation and other systems can feed back to my control mechanisms, and I don't have to have a 30-day review board about changing my plant, then suddenly my plant can make more money, which at the end of the day is the purpose of these enterprises. So these things are going to have places. It's just how do you fit them in and how to use them. So we bring up the cloud, and the cloud scares everybody in this space, and the cloud scares everybody everywhere because it's like I'm giving my computing somewhere else. But what does that buy me, and how can I do that, and what does it do with respect to reliability? What does it do with respect to resilience? What does it do with respect to the network connectivity that I need? And there are going to be use cases to where the cloud is going to do that for me. It may not be that the thermometer in a pipe that's connected to a little device that sends ones and zeros somewhere immediately goes to the cloud. But if I have a pipeline across the middle part of the United States, and it's, say, 1,500 miles long, why not take each one of those sensing points, toss them to the cloud, and get them back? If I can build cloud systems that solve those other resilience questions, reliability questions, because it'll be cheaper, it'll provide better opportunities for things. And so it's a matter of finding what fits the right problem, as opposed to putting on my glasses and say, I'm sorry, we don't do cloud.
It sounds like you've argued for using the cloud where there's benefits. The controversy is not using the cloud per se. It's not just, the cloud is the cloud and we don't want to use it. In my understanding, the controversy, a big part of it is connectivity. If I have my sensors connected, you talked about maybe not directly connected out to the cloud in the internet. There might be a step in between connecting out to the cloud and the internet. Still, it's a very short, in a sense, conceptual distance between the sensors and the internet exposed cloud. If that internet exposed cloud is compromised, as the Kisea device, the Kisea system, cloud system was compromised, you've got an opportunity to drop ransomware and other nasties into thousands of industrial sites simultaneously, or all of your pumping stations simultaneously. That's the risk. Are we looking at that risk through the wrong lens? What lens are we looking at here?
I think that it's very important that we see those risks, because you bring up examples that have happened, and I think that we can learn from every example that's happened and say, why did this happen? If you just are going to pick up your network and replace it with a cloud solution, or replace it with a software-defined networking solution, without consideration of how do I do it differently in these environments to maintain my resiliency, maintain my reliability, How do I do it differently in these circumstances that gives me the benefits of those? Because there's no benefit to the more complexity, then why would I do it? And so it's not just a wholesale boom, replace, done. It's looking at what do I do with this? How do I reestablish my overall objectives? And so it's not a replacement, it's a re-engineering process. And the re-engineering process opens things to us that we don't have today. Like, where am I doing my computing? How am I doing my computing? And so just as SCADA systems are different from DCS systems, and the people that are out in your audience that heard that statement, that understand that statement, will say yes. And it's because they're solving different problems. And so we have to be very careful on our lenses to be very specific and not call a DCS solution a SCADA problem and not call a SCADA system a DCS solution, just like I can't just automatically use the word cloud somewhere. I have to be very specific in my definitions, my languages, what I'm trying to do. And we're going to find that when we get that way, then we can communicate and come up with the answers that solve the problems that we don't have a solution to today. And the cloud will solve problems. It will bring problems. It's our job to put the right lenses on to see those in advance and capitalize on one and prevent the other.
All right, you'd mentioned there the case of Kaseya, which I think is a good example to bring up. For those listeners out there who don't know or may have forgotten in the meantime, Kaseya is a cloud services provider, a remote monitoring and management company. A breach of their systems, by virtue of the fact that they provide cloud services to all kinds of companies, over 1,000, ended up leaking into the IT systems of, 1,500 companies or something. So this is what I think makes people really worried when we talk about these issues.
So yeah, when Kaseya hit in the middle of 2021, I was actually quite disappointed. I mean, at the beginning of 2021, I had put together a prediction predicting that supply chain attacks, cloud-based attacks, were going to start being used by ransomware groups to distribute ransomware to large numbers of sites at once. I was disappointed because I'd made this prediction and I was right. Nobody likes to be right about a negative prediction. And in terms of lenses and perspectives, I think a perspective that a lot of us have, a lens that a lot of us look at the world through, is how important are we? Is any of us important enough to be the target of a sophisticated nation-state attack? And most of us say, no, we're just not that important. To me, that's the wrong way to look at the problem, because what we're seeing is that the ransomware groups are only about 5 or 6 years behind the nation-states. Whatever the ransomware groups see the nation-states doing. I mean, the Russians are accused of distributing NotPetya as a security update to a Ukrainian tax package. It was a supply chain attack through a website, in a sense, through a cloud service. 4 years later, again, the Russians were accused of compromising the supply chain, compromising a security update in the SolarWinds Orion product. And sure enough, 4 months or 6 months after that, ransomware groups hit 1,500 sites through Kaseya. So, saying we're not important enough to be the target of a nation-state attack is the wrong way to look at the threat environment. Saying what we see the nation-states doing today is what the ransomware groups are going to do to us in 5 years' time. We better get ready for it, because the ransomware groups don't ask how important are you. They ask, do you have money? And pretty much everybody with an industrial control system has got enough money to be a target of ransomware. That's the right way to look at the question of who's coming at us through the cloud.
So if you had predicted that something like Kaseya would happen 6 months before it did, what is your prediction now about what might happen 6 months down the line?
Well, I'm not sure I have a prediction off the top of my head, but something I have been thinking a lot about is this supply chain issue. We may be asking the wrong question. We may be looking at the supply chain problem through the wrong lens. A lot of us are asking the question, what happens when one of our suppliers is under the thumb of a hostile government? Under the thumb of a government who can order them to insert backdoors or malware or other nasties into their products that they're distributing to customers like us. Well, that's the question we're asking, but that's not what happened with NotPetya. A government is accused of inserting it into a software update for somebody else's tax program, not because they forced the supplier to do it, because they hacked into the supplier. That's not what happened with SolarWinds. No government ordered SolarWinds to put a backdoor in their product. They hacked into it and inserted it against the will of the supplier. That's not what happened with Kaseya. No government leaned on the Kaseya and said, "Hey, distribute this ransomware for us." They hacked into it. So, I think we're asking the wrong question. We're looking at the problem the wrong way. It's not so much what happens if a government leans on a supplier. It's what happens when a supplier gets hacked. It's what do we do when bad stuff is coming in through trusted suppliers for any reason, because a government leaned on them, because they were hacked, by a nation state powerful enough to defeat all of their robust security defenses. That's the question. That's the lens we need to be looking at the supply chain problem through. Can we talk about industries? Is what you've been saying sort of universal across industries, or do we need to specialize this for different industries?
Well, the answer is yes. It is universal, but we also need to specialize. We need to pay attention to our industries. And let me go back and say, if a human's involved, their lens is involved, their bias is involved, their perception's involved. So that part is not going to change. Lenses will be part of this. But more importantly, if I'm in the electric industry, am I going to look at things a certain way? Yes. Am I going to look at them the same way as the person in, for instance, manufacturing would look at it? Or a nuclear power plant? Or a pipeline? Or a chemical industry facility? It doesn't matter what critical infrastructure you're in. We use the same little gray, white, black boxes to control things. We all use ones and zeros. We all use engineering. But it's constrained by different purposes. So our security policy in a place that could go boom is going to be substantially different than in something where it might cause an environmental disaster. It might be different than something that causes the lights to go out. So each one of these is going to have its own set of biases and concerns and lenses to prevent the various things that they want to avoid. Everybody wants to keep their stuff up. Everybody wants resiliency. Everybody wants reliability. Everybody wants 100% OT all the time. Matter of fact, if they could find a way to crank it to 110, they would. But if the differences in the industries come about by unique physics, unique circumstances of the industries, and so people in that industry have built lenses to focus on that, to make certain they're aware of that.
So that was a bit of an abstract answer. What I took away from Art is, consequences differ. And in different industries, the consequences of malfunction, the consequences of compromise are very different. And, the severity of the consequences is going to determine, your perspective in terms of how much security is enough, what kind of security is adequate. Concrete example, let's compare power transmission with power distribution. Power transmission is the grid. It's what takes power from power plants to entire cities, entire regions in a geography. If a major transmission operator drops, the entire grid is at risk. you risk a multi-hour outage of on the scale of something like the 2003 blackout in the Northeast. But contrast that with power. So you really need that infrastructure to be ultra reliable and very secure. But contrast that with power distribution. There's a reason that in North America the NERC CIP rules mostly apply to transmission. They don't so much apply to distribution. I mean, I live in Calgary. In my subdivision, a couple of times a year we have a power outage of a couple of hours. What are the consequences? They're minimal. The consequences of the entire grid going down for a couple of hours in a cascading failure, that's huge impact, versus one subdivision not having power for an hour, not a problem. And this is the reason that we see these differences in perspective as to what kind of security is appropriate to the two industries, the two circumstances. Okay, well, thank you, Art. It's been great having you again. Before we let you go, did you want to sum up? Is there a thought you want to leave with our listeners?
Thank you, Andrew. This has been a wonderful opportunity to explore these things. I've enjoyed discussing them with you. I think that it's important as we leave that I just want to make sure everybody understands this isn't about the lens per se. This is about problem solving. This is about using information we have to solve problems, and the emphasis on the we. If I want to solve a problem, I will get better solutions if I bring other lenses to bear. I'll get better solutions if I have multiple parties at the table in an open environment, whereas people say, can we expand the pool of candidates? Can we expand the pool of solutions? What if? What about? Rather than shutting everything down because my lens won't accept outside inputs, my lens says, I don't see your point of view, I think the important thing to look at is our problems will all be solvable as soon as we get enough smart minds in the room and enough egos out of the room that we can get rid of the lens problem, and everybody brings their own thing with their lens, but then together we come up with a solution that combines the best of those. And I think OT is an ideal situation for this because there are a lot of things going on in OT that have to work together to make this work. And so it's not just the physics, it's not just the computing, it's not just the operators, it's not just user interfaces, it's everything combined that makes this work.
I think how Art ended there resonates with a few of our guests in the past, really with the whole show. Our show's about bringing lots of different voices to the table, maybe introducing a perspective that you haven't heard before. We've had a lot of guests who have dealt with this very issue from any number of perspectives, whether it be IT-OT convergence, how to get these two different sides to talk to one another, whether it's Joe Weiss talking about bringing engineers to the table when you need them, the value in having different ways of looking at these problems and, sort of the benefits you get from that therein.
I think that's exactly right. I mean, a lot of the guests in the discussion we've had in the past, I don't know, what is it now, 60 episodes, have focused sort of on the conflict, on the problems of people having, different views of the elephant, different perspectives, and, trying to get them to agree. But, I think Art's point really is one that I've heard a couple of guests echo. It's about cooperation. People do legitimately have different perspectives. Each of their perspectives has value. Bring them to the table. We make better decisions together than we do independently. So I think that's an important lesson.
Okay, well, thanks to Art Conklin for speaking with you, Andrew. And as always, Andrew, thank you for speaking with me.
Always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone listening.